Hello everyone. In this situation, I am considering a square plate of side A and mass m. Length of each side is A and its mass I am considering is m. And it is moving to right with a velocity v. As it keeps on moving along the horizontal direction, this surface I am considering here is a frictionless surface. Here there is an obstacle, a small obstacle on its way. What happens as it keeps on moving to the right? After coming to this point, it hits with this obstacle. Now the question is, what should be the minimum velocity of this frame to the right side direction such that it tips over it? I wanted to calculate minimum speed of this frame such that it tips over this edge and it rolls over it. For this purpose, I am considering the situation when it hits it. When it is hitting over here, what happens? Okay, so here about this edge, this frame should rise up and it should roll over like this. That is rolling over condition I am showing you here. Like this, it should rise up like this about this point. Okay, so when it is rolling over about this point, okay, I'm applying conservation of angular momentum about this point. So let me call this point as O. About this point, I'm applying the conservation of angular momentum. Initially, about this point, what is the angular momentum of this frame? Initial angular momentum Li is equal to m into v into, okay, the perpendicular distance between this axis of rotation and line of action of velocity. This height is a, because of which I can write it as a divided by 2. Okay, this is the initial angular momentum of this system about this axis, and it is rotating in which sense? In clockwise, so it is minus k cap. Okay, after hitting, what should happen? About this point, it should undergo a pure rotation. Am I right? So that only I am writing here. So about O, I am writing final angular momentum about O is equal to, what happens till the point it comes and hits this obstacle, it is undergoing pure translatory motion. When it is tipping over this edge, instantaneously it is at rest. So because of which it is undergoing pure rotatory motion about this point O. That only I am writing. Angular momentum, final angular momentum about O is given by IO into omega. What is IO about this point? This is center of mass. About its center of mass, it is nothing but a rod of length A. About its center of mass, how much it is? M A square divided by 2 Ig plus, I am using parallel axis theory to find out about this axis. About this axis is M A square divided by 6 for a square plate, M A square by 6 plus M into square of the distance between this point and this point. That is this length I want. So distance from here to here is how much? A by 2. This is A by 2. This will be how much? A by root 2. So A divided by root 2 whole square into omega, which is rotating in this sense, no? Because of which minus k cap. So if I apply conservation of angular momentum, what I'm going to get here? M into V into A divided by 2 is equal to, what are you going to get here? M A square, if we take it as common, 1 by 6 plus 1 by 2 into omega. I'm dropping this k because both of them are along k direction. Okay, this is what I can write based on this. So A gets cancelled, mm also gets cancelled. So V divided by 2A into, so LCM is 6 to 3 plus 1 plus 3 4, 4 by 6, 4 by 6 you can write it as 2 by 3, so 3 divided by 2 is equal to omega. This is equation number 1. Next, when this body is undergoing pure translatory motion, the center of mass is at a height of a by 2. When it is about to tip over, at least it should come to this configuration, after which it can roll over this point. So if it is not able to, that is, the kinetic energy is not able to raise the potential, raise the center of mass through this much of height. What is this height? This height is a divided by root 2. Distance from center to center of intersection of diagonals. Center of corner to center of this square plate is a by root 2. So initially the center of mass is at a height a by 2. Now when it is about to tip over, center of mass is at a height a by root 2. So the initial kinetic energy should be good enough for this particle to rise the center of mass from a by 2 to a by root 2. Then only this particle can tip over. Now at this instant, applying conservation of energy. Conservation of energy. Conservation of energy. Okay, so before it is tipping over, what is the total? When it is tipping over, what is the total energy? It is under pure rotatory motion. So half I into omega square. All this I O into omega square. Okay, all this kinetic energy should be converted into potential energy. That is m. All this kinetic energy should be converted into change in the potential energy. So mg into final height minus initial height, that is equal to mg into, what is the final height? A by root 2. A by root 2 minus initial height is how much? A divided by 2. So from this expression we know the value of omega. Substitute here. 1 by 2 into, what is I naught? I naught is, just now I calculated here, this whole m into a square divided by 6 plus m into a square divided by 2 into, what is the value of omega? Just now I calculated here, 3 divided by 3v divided by 4a whole square should be equal to mg into, okay, so if we subtract this, how much you gonna get? You can write it as root 2 into root 2. Am I right? Root 2 into root 2. So 2 is the LCM. So root 2 into root 2 is 2. So if you multiply and denominate by divided by root 2, no, you will be getting root 2. Root 2 minus 1 into. Okay, through this we can find out the value of it. How? This value is how much? This 2 gets cancelled. So m a square, if you take it as common, this value again it will become 4 by 6, that is 3 by 2. This is 9v square divided by 16 a square is equal to this one. All through this, what I can cancel? M gets cancelled, a square gets cancelled. Okay, 9 3 is a 27 v square divided by 16 2 is a 37 is equal to what you can write? G into a into root 2 minus 1. Therefore v is equal to how much you will be getting? 37 g a into root 2 minus 1 divided by 27 whole power 1 by 2. This is the minimum speed with which it should move to the right, such that after colliding with this obstacle, it will be in a position to roll over.